going to look at completing the square, which is essentially, we should talk about what it's useful for. What it's useful for is going from one form to another. So the form we're in is our standard form. Okay, so standard form is ax squared plus bx plus c. Okay, and what we're going to do is we can only complete the square when we're in this form. So if we're in Vertex, which we wouldn't be because that's the whole goal of this. The whole goal of this is to take it to the Vertex form, and it's by completing the square. We'll call it CTS, okay? And the Vertex form being this. Okay. The whole reason we do this is so that we can find out where the vertex is and graph easy. Essentially, when we're in standard form, it's very hard to see what the parabola would look like in terms of graphing. But when in vertex form, we know we can plug in a vertex and we have an idea what it's going to move up or down by each of the values because of our A. It's much easier to graph when we're here than obviously in standard form. Standard form, we just kind of have to plug in and do trial and error. So that's the reason. Completing the square is a long process, so we'll kind of talk about how to go through it. What we're going to do to complete the square is the very first step to it. So we'll rewrite this question again. 2x squared plus 12x minus 3 is the very first step is we're going to divide the first two terms in the question. Okay, so the very first two terms, that's our a and our b. We're going to divide them both by the a value. Okay, so here we go. In this case, the a value is 2. Okay, so because it's 2, we're going to common factor 2 out of both these two terms, not the third term. You could do it that way, but it gets a little more complicated, so we're just going to focus on doing it to these two terms. Okay. When we do that, essentially the next line is going to read f at x is equal to, the common factor is our 2, we took it out, and what's left, well, when we divide the 2's create a 1 or cancel out, and we're left with x squared, and here 12 divided by 2 is 6x, okay, minus 3. So now what we have is, consider this our new b value, okay, and there's a small formula here. What we do is with this new b value, okay, I'll call it bn just for our small formula is bn, the new b value, squared divided by 2, okay. So what you're going to be doing here is you're going to divide this value by 2, and then you're going to square it. Okay, so that's the order. You're going to divide 2 and then square. So our number is 6. So we're going to take 6 and divide it by 2, and then we're going to square that value. So 6 divided by 2 gives us 3, and then 3 squared is our 9 value. And what's important here is we're going to be using plus and minus 9. We're going to use both of these values. I'm going to talk about why. The reason we needed that number is because what we're trying to do is create a perfect square trinomial inside the bracket. So x squared plus 6x, and I'm going to add and subtract 9. So I'm going to add 9 and subtract 9 within that little bracket. Okay, so imagine that this bracket here is now expanded. Okay, and we've added plus and minus 9 in there. We still have the negative 3 on the outside. The reason we can do that is because what if we combine these? What is 0 or what is plus 9 minus 9?
0.
0. So it's essentially like saying plus 0, which is great because it doesn't do anything. It doesn't actually change any of our equation. That's why we're allowed to essentially do this. And the point of this, I'm going to show you, is to get these three terms together, because this is called a perfect square trinomial. That's how we built it. We use this thing there. And we'll talk about how factoring that is special. But before we can do that, I got to get rid of this negative 9. In other words, I got to take it outside. Now, the problem with that is I have a 2 in front of this bracket, which really means, according to BEDMAS, is we should be distributing this 2. So I can't just start dropping things out without distributing the 2. So to take this negative 9 outside of the brackets, it has to be multiplied by our a value, okay? Our a value. And in this case, our a value is 2. So when we take negative 9 out, we have to multiply it by 2. So the next line will read f at x is equal to 2 x squared plus 6x. We still have positive 9. The negative 9 came outside of the brackets, and now negative 9 times 2 is negative 18, okay, minus 3. So that's how we get that negative 18. We have to make sure we multiply by our a value. Okay. Let's collect these two like terms at the end before we get into our next step. X squared plus 6x plus 9, and this becomes negative 21. Okay, great. So we're really close to what we need to do. Technically, what needs to happen here is we need to factor this. Okay, and when we factor this, you can quickly do simple factoring. Because this is only a value of 1, we can think of two numbers that multiply to positive 9, and they add to positive 6. Well, that would be 3 and 3, right? So in other words, if we were to factor this, and I'm going to do the factoring kind of on the side here because I'm going to show you a really quick step. With x squared plus 6x plus 9, we just did the simple factoring, so we know it's x plus 3, x plus 3. Can I simplify that? How can I write that?
X plus 3 squared.
Yes. And the whole goal here is actually to create this answer. And because we've done this step on the side here, where we used that our new b value divided by 2 and squared it, it actually creates something that every time we factor it, we're going to end up with this. Okay, so instead of actually having to go through our factoring, because we know we've created this, we can do a little shortcut. And the shortcut can be square rooting the first and the last term. Okay, what is the square root of x squared? X, okay, and we're going to put it into a bracket that's squared. And we have our minus 21. So the square root of x is x, so I write that as my first term. Square root of 9 is?
3.
3, okay. And whatever the operation in front of the middle term is, we bring that down. Okay, so in this case it's positive, so we write a positive in here. And lo and behold, x plus 3 squared is exactly the answer we got here. And it just so happens this is our vertex form. If you remember from above, our vertex was f at x was equal to ax minus h squared plus k. And there you go. You got your h, your k, and your a value. Okay, so that's the long explanation to completing the square. You might be able to jump steps, but that's the entire idea behind it.